Howdy. Oh my god. Okay. I think I'm good. Okay. Basically, I am going to be working on my Raspberry Pi thermal camera. Just getting everything set up here. Okay. One moment. One moment. Okay. So, this here, as you can see, is my thermal camera. And it works. It has you can't really see it very well on stream, unfortunately, but it has the bicubic and bilinear filtering, and then you can flip horizontally, flip vertically, and then you can rotate. So we got all those functionalities. And then of course you can stop the program and close it. So now what I want to do is I want to be able to, when you have the settings clamped, I want you to be able to adjust the upper, you can adjust the upper ceiling and the lower ceiling. One moment. Let me just check something. One moment. My God, these cats. Cool. One moment. Let me go get my cats. There we go. Let me go get my cats. Thanks. Okay. need human interaction. Okay. Binks is in the office. He just wanted some human interaction, I think. We'll see. Yes, Binks. You can see him in the back there. Okay, anyway. Let's go actual to the code now. So what I'm going to do is I'm going to add in this functionality, and then I want to basically create a struct of some sort to handle key presses, because it's just kind of messy with what I got right now. So let's do that. So let's do increase the ceiling temp. So let's see. A moment. Another cat wants inside. Milo's now here. Okay, now let's get coding. So if current key state, so basically to set the up, basically to set the what do I want to do? Which one do I not have? I have, let's see, I have key left, key up, key 1. Let's do key down. So let's say if current key down state equals 0 and current, let's say the current key down, and then hang on. So I'm sorry. I'm just trying to think here. Let's see. Key 1, key 2, but key 3 is not being used. So let's say key 3 state is being held down. If key 3 is being held down, and I go up and down, that'll do the ceiling. And if I do key 3 left and right, that'll be the lower bound. Okay. And then to decrease the ceiling temp, down, and to increase the floor temp, with key right, and I'll do key left. And then I'll do take picture, take video, because I wanna do that. I wanna be able to take a video and take a picture and save it to the SD card with a timestamp. I think that'd be pretty dope. So let's do that. So let's figure this out. So then what we're gonna do, we're gonna take min actual temp plus equals 0.25f minus equals 0.25f max Okay. Let's try building this. What? Hang on a moment. What the? Hang on, I'm sorry. We have a security camera out back, and there's someone going up and down. Looking for something. Huh. Well, that's very strange. Huh. Anyway, let's try running it. Okay, now let's try increasing and decreasing. So key 3, and left to right is going to do the lower. Well, actually, key 2 is going to change clamping mode. Key 1 is going to change interpolation. So let's move and hold key 3 and key left. Why is clamping mode not working? What? Oh my god, Ducat is so annoying. Ah, I see. Because there we go. Let's try that. There is a cat behind my curtain. moment. That's unfortunately I wasn't able to get a good video there. Good. Let's try this. So here, we're going to change the interpolation mode. We're going to hit clamp. And we're going to hit clamp. And we're going to hit clamp. And we're going to hit clamp. Okay, so then that works. Now what I'm going to do is I'm going to hit key 3 and left to decrease floor temp. Let's hit key 3 and right and increase floor temp. And hit key 3 and up, increase ceiling temp. Oh, you know what? Okay, so what I'm running into right now is, first of all, that's absolutely insane. What I'm running into right now is I don't have a break. Okay, seriously, what is going on? Why is that webcam so garbage? What? Why is that webcam freaking out? Okay, I don't know why that was so weird. Basically what's happening is I don't have a break. So as you can see, there's some cat paws in the video here. Okay, I'm just trying to think here. I think what's going to happen is I'm going to take double key presses and I'm going to take these and I'm going to move them above these This is just for right now, but you know, we all know there's nothing more permanent than a temporary fix, and I will do else ifs instead of ifs. Can you not right now, Binks? My God, my cat is an absolute menace here. Sorry, Amanda's cat. He's both our cat, but he likes Amanda more. Milo likes me more. Let me go look and see where he is. There he is. He was behind my computer. Jeez. Okay. Kind of chaotic stream here. Anyway, let's try building this. So we're going to close. And then we're going to make J4. Hello. Thanks. Oh my God, I keep messing up their names. I don't even know why. And then thermal code, thermal app. Here we go. So now, if I hit right, it should rotate. Up, it should flip vertically. Left, it should flip horizontally. Then I should be able to clamp it. And then I should be able to change the filtering to bicubic. Then I should be able to change the lower. And upper. Lower is increasing, upper is lowering. Okay, so if I keep 3 being the mode button, not assigned to anything, then this should work. And then I can hit clamp again. And then hit the smoothing. Okay, so that works. Cool. That works. Okay. So take picture. I want to down here if and key press state equals 0. Prev key press state equals 1. Okay. Now how do I let's figure this out. How to my god, these cats. Okay, they gotta go. Okay, it's time to go. It's time to go. You guys don't really. Okay. Yep, they're very annoying. Hmm. What is the final? Hmm. Jesus. You would think I know how to do streaming by now. Okay, so this, I'm going to save this first as a screenshot. So basically what I'll want is I'll want to include the bitmap header. The bitmap header bitmap header is something I need to write. Okay, so basically okay, so this does read bitmap, but that's not what I want. I want like a save bitmap. Let me okay, let me do this. Bitmap lib bmp utils.h bmp so let's do pragma once. Cool. We'll do that. Include cstdint. That's for the int16s and all that. Pragma pack push one. This is basically ensuring that the structures are packed, no padding, because padding is a problem. So yeah, just be aware of that. And then of course pragma pack pop, what you want to do at the end of that. Cool. And then type def struct BMP info header. This is going to be version 3. And then type def struct BMP info header bit masks. So this is going to be the bit mask for the bitmap header. Here, let me turn. I'm so sorry. A moment. There. Now you can see what I'm doing. So let's do UN32 T red mask, and then blue, green, cool. Then let's do the actual file header. So we're going to do file type. So you 16T BF type. So BF type is going to be BM, right? Bitmap. So bitmap is going to be 0x4D42, right? And then UN32T BF size, total size of that bitmap, UN16 TBF reserved 1. It's just, don't worry about this because there's a couple shorts that are reserved. And then UN32. And this is going to be your offset. So offset from the beginning of the file to where the bitmap data is going to be. So then we have to make the actual header, which is going to be another really long nightmare. It's going to be UN32 T bitmap size. So the header is going to be 40 bytes for version 3. Int 32 T bitmap width, int 32T bitmap height, right? Okay, and then int 16T bitmap planes. It's going to be one color plane. Int 16T bitmap bit count. That's per pixel, so 1 bit, 4 bit, 8 bit, 16, 30, 24, 32, that sort of thing. Like that. And 32T bitmap compression. This is going to be a compression type 0 for RGB and compressed, right? UN32 bitmap size image, right? Size of the image. Data and price can be 0 for bitmap RGB. Int 32 T bitmap x pixels per meter. This is pixels per meter. It's just like, isn't this nuts? And then UN32T and that clear used 0 for 4 color. UN32T bitmap clear important. And then, yeah, that should be good. And then let's do a bool to save the let's do a bool function. Save RGB 565, right, we're doing 16 to BMP. Okay, const char file name, const un16 t pixel data, int width, int height. Looks simple enough. Right, let's change that to okay. Okay. Include BMP utils h, include stream, that's for files. Well, let's do row padding for the vector and then include IOStream for errors and stuff. This is just for debugging purposes. Okay. And then we gotta make this function. Okay. So basically, I'm thinking, I'm reading. So apparently, there's a way for videos, you can just straight up use FFmpeg. So if you have FFmpeg installed, you can use system to run FFmpeg to store your videos into a stream. That's kind of nuts. So actually, the hardest part of this is actually going to be the screenshot, not the other one. Now, I could probably do like a save to ppm, because I know that saving to ppm is pretty easy. But we're in too deep, so let's get this done. Okay, let's get this. So okay. Std IO stream out, std stream binary, right? Because you want to have a binary. If not VMP file, then you see error cannot open file name for writing. Then let's just do std and line. Return false. Okay. So now the bitmap files. Bitmap rows are padded to be a multiple of 4 bytes, and then for the RGB565, which is 16-bit, 2 bytes per pixel, padding is needed if the width times 2 mod 4 is not equal to 0. So bytes per pixel equals 2 int row stride, because we're going to be doing strides unpadded, equals width times bytes per pixel, right? Okay, so bytes per pixel is 2. Then the width you're doing is going to be twice that, the row stride, right? Okay, then int row padding bytes equals 4 minus the row stride unpadded, so double, mod 4 mod 4. Okay. And row stride padded equals row stride unpadded plus padding bytes. Okay. And then we got to set the file header. File header dot bf type equals 0x. What was it? It was 4d42, right? Which is bm. Okay, file header dot bf served 1 equals 0. Okay, now for RGB565, if the header might be large, has a bit master located directly after it. Here we use the standard v3 header, so uint32 t info header size equals size of bmp info header v3. Okay, got that. System of data, right? So file header of bits equals size of bmp file header, right? The file header plus info header size, file header wf size. Yeah. Equals header bf off bits plus static cast to T. Row stride padded times your height. Okay. Basically the entire size. Okay. I gotta prepare the info header. Version 3. MP info header v3. Info header dot size equals info header size. Makes sense. Info header dot width equals width. Right, 16-bit. Because I'm doing RGB. I'm not doing anything special. A lot of these are just 0. Now I gotta write the header right. Man, I haven't done reinterpret cast and stuff in a long time. Now I gotta write the pixels. Which I think I'll make need to make a vector of. So basically rotating bytes and add zeros. Okay, now here comes the actual writing. From the bottom up. So this is just a cheap way to do 2D with 1D. Okay. See if it works. Okay. What's going on? What do you mean file name? I know I could probably just use the extant file header. And I would like to. God. Okay. Let us do include. Okay. Cool. Okay. Now let us go to KB hit, and then let's do get current timestamp. So the string is going to turn a string. Get current timestamp. Okay. To core folder later. Everything is just being done later. I'm doing a timestamp. If you just joined, I'm doing a timestamp so I can save a screenshot from my thermal camera to a file, and also video. I must say video. Now it goes time 0. Makes sense. Got your current time. Goes local time. Now time T2 structure. So basically, you gotta like. Okay. Cool. I'm thinking, figuring this out. Okay. Okay, so create a string stream to format the timestamp. Okay, this is okay. Then I want year, month, date, hour, minute, second. So OS is 1900, right? Plus local time, time year. Okay. And then we're gonna add std set fill. We're gonna pad with zeros, right? Std set width 2. Yep. Because set fill and set width, this is just setting up the stream. 1 plus LTM TM Monday. Okay. We're doing sorry, I'm stupid. Monday's not Monday. This month. And then we're gonna do the same thing. Okay. To local time. Month of day. And then we're going to do a underscore. And then we're going to do local time. Time, hour. And then we're going to do local time, time, minute. And then we're going to do local time, time, second. Okay, simple enough. Turn the string stream to a stream, and then yeah, I kind of want to put this in like utils.h. So you know what? Let's do that right now. Okay. Okay. Let's try building it. Of course. Ah. Try that. I'm going to find a reference to get current timestamp. Where is this? Um, sworn I did the sync files correctly. I guess not. Oh, you know what? Actually, let's try that. Okay, let's try it. Wait, hang on. Okay. Look at that, folks. Look at that. I've saved the screenshot. It's right there. I've saved the screenshot. Using a bitmap header, a bitmap routine that I wrote myself. That's sick. Let's add let's rebuild it, make sure that it works, the screenshot folder location works, and then let's try let's start recording video. You know? Yeah, let's start recording video. why is it? Why is it taking a whole bunch? Here we go. This is why. Because never because it never reset. Interesting. Let's do a bicubic filtering. It's just cool. Yeah, it's so cool. Look at that. That's bicubic filtering. Look at that. And if I really wanted to, I could run it through the filter again to make it even better, but that's not really the point. I think this looks black, but it's not actually. That's so cool. That's so cool. Let's do this. And basically, after I get this, I will put this in like a better better state. So basically, like the key presses are a mess. I want to put that into like a struct to just make it a lot nicer. I kind of got carried away tonight with the features. It's totally fine. Cool. Okay. Oh, Des, where have you been? Bro. Been here for a while, making good progress. We can take screenshots now. Ugh, I gotta lock the fuck in right now because I want to take video recordings. Um, is FFmpeg installed on this thing? Yeah. We're gonna build OpenCL. That's fun. OpenAL. Yo, Des, let me show you what we're working with here. So we're gonna take a screenshot. Okay. I'm gonna take another screenshot here. Remember, this is auto gain, so okay. I'm gonna refresh this. Look at that desk. Look at this. This is what the sensor sees. This is what it sees. It sees 8 by 8 pixels, and the granularity is 0.25 degrees Celsius. So from that, with my bicubic filtering, I'm able to pull something like this. That's a thumbs up. So right now I want to do recording a video, and then I want to clean up the button code a bit so it's like in a state machine instead of like writing down a whole if stack, because it's kind of a nightmare. But then after this, and they get like the battery pack installed and stuff, I want, yeah, that's my arm, and that's me doing a thumbs up. It's upside down. But what I want to do next is, like, once this is sort of locked away, is I want to do multi-frame sampling so that when you move the camera around slightly, because if you're holding it, it's not going to be perfectly steady, those little scintillations you do will slightly shift your pixel perspective. And if you add those all up, you can get a frame that is like 128 by 128 pixels. It won't be bigger, it'll be the same size, but it'll be much higher resolution. Now it'll introduce like some latency, but if you don't care about latency, you can vastly improve the apparent resolution of your camera without improving the sensor. And there's ways to do that with just motion from the video signal. But the problem is that this is very noisy, and I don't know if like doing noise algorithms against an 8x8 image is going to be really useful. So what I have, I didn't get it for this, but I'll get another one for it too, is an optical flow sensor. And what the optical flow sensor should do, if it doesn't work, I'll use a 9DOF. What an optical flow sensor should do is it should allow you to see where or how the whole thing moves. Optical flow, it basically reports moved pixels, not the actual image. There's some there's like some processing on it that will do X and Y stuff. I don't know about rotation. But yeah, had too much nerd shit, dog. You're like building 3D engines in TypeScript. Let's talk about nerd shit. This is my bread and butter. This is what this used to be my job essentially. I'm much better now. I absolutely love this. I love this shit. Love it. So anyway, let's cut the nerd shit. And let's see if I can't do video recording. Because I got screenshots. Let's do videos. Okay. Let's go up to the top of my main. Bool is recording equals false. Okay. And video frame count equals 0. Yep. CD string current. Oh my god. Current video frames path. I wish there was like a way to do like a linter against SSHFS. I'm sure there is, but you know. Constant video FPS equals 10. Now the frame rate's going to be 10 because what's really interesting about sensors, infrared sensors built in China, is that for the consumer level, not things like FLIR where you buy the $800 thermal camera that you use for like home inspections, but like little sensors for like Adafruit, it cannot be more than 10 FPS. It just can't, which I think is really stupid, but just like some weird like technology restriction, we just can't. It's just not allowed. Now I've definitely had thoughts of like having a few sensors and then somehow clocking them so that they're offset from each other by like a third of a second. And if you have them all together next to each other and then run down the line repeatedly, you could essentially have a 30 hertz sensor using 310 hertz sensors, but I've never gotten into it. The method is to implement AI into it and generate frames. You're not wrong. You're not wrong in the fucking slightest. I think as a sort of stretch goal for this, I definitely will be looking for like a lightweight model that can run on the Raspberry Pi, because this is running on Raspberry Pi Zero. Let me show you what this is running on. It's running on this Raspberry Pi Zero. This is the LCD. So it needs to be really lightweight, but I think it could. I have high hopes for that sort of thing. But we won't do that today. But we will do it. Okay. So now let us usually the frame generation has to be lightweight or else it's not really a benefit. Exactly. Yeah. This has to be super lightweight. I think the RAM on this thing is 1 gig. There are like lightweight AI models that you can load on like STM32F4s, but it's not really AI at that point. It's much more of like it's just like a machine learning algorithm or like machine learning weights, that sort of thing. Yeah. Okay, so basically, if I'm not recording, I need to change this recording to true, and then basically I need to, I gotcha. This is what I need to do. Okay, I gotcha. Okay. Okay. Now, then is recording equals true. Video frame count equals 0. Because we got to reset everything. Current video frames path equals video frames LCD and plus get current timestamp, which I've done before. It's an absolute nightmare. std string command equals gotcha. There we go. We'll do that. Make dir p plus current video frames path. So basically, you're going to record a bunch of images, and then you're going to use FFmpeg to save it all to a video. And then system command.c string. Okay, then std cout. Recording started. Leaving frames to current video frames path. Now I probably don't need to do like C or C++ for this, but I have. and then else is recording equals false. See out. Okay, this is where the, oh crap. This is where the recording happens, or the, so then std string out put video name equals video thermal video lcd plus get current timestamp. Okay. Okay, now we're gonna build up our string to run through FFmpeg. Make a game using Heat. Is Heat a language, or do you mean like an actual game using the Heat? That would be kind of fun, like try to like use Heat to like hit something, like Pong. You know what? We'll put that in a stretch goal. Okay, we'll put that in an absolute stretch goal. Not right now. Right now we're doing video. Okay, we're doing video. We're gonna stay on task. Yeah, using Heat, yeah. Now, I think FFmpeg on the Raspberry Pi by default doesn't have, we have 264, I don't think it's 265 enabled HVAC. I don't think that would make sense if it would. Yeah, I don't know if that makes sense. Your V, right, the most default, right, 4 to 0 to Y, output video name. And then I'll probably put these all in a log later. And then let's run it. FFmpeg command stream.string .c string. Right, and then let's just check it if ret equals 0. It is STCR. It's the same thing, effectively, but it's different. Video encoding failed. Ensure FFmpeg is installed. And it should be by default. Okay, now save frames during recording. So basically, I think this should do something. Okay. I'm just no. Okay. I think I just take this, copy that. Okay. Because that's the same code that I will use. Same code. Okay. I could do this every frame anyway, but I only want to do this when I'm recording or taking pictures, just to save on processing. So then I should be able to just save it. Basically the same thing here that I did for saving screenshots, but just do it a little differently down here. So and std set fill 0. Set width. So basically what's going to happen is you're going to just basically take a bunch of frame pictures up to like 10,000, like 100,000, right? And you're just going to name them that. and then you're going to .565 because it's 16-bit. We're almost done here. Let's just try building this and seeing if this does anything at all. We're just fixing up some errors here. Okay, let's try this again. Command, oh my god. Let's try that. It's just misspellings, dude. Okay, it worked. Okay, so let me okay, so now if I do F3 and the center button, I should start recording a video. No, sorry. Okay. Wait, what? Hey, whoops. Hang on. Okay, that crashed. Could not find a file path video frames. What did I do? Let's try refreshing this. I did. It is address 69. Address 69 is the thermal sensor. Yeah, those. Yeah, okay. Well, wonderful frame. Okay. Let's try this again. I should probably run, eventually I should run FFmpeg in the background. Or like with no pipe to like null or something. Okay. Well, that didn't work either. Okay. Let's try this again. Come on. Let's actually see something work here. Okay, why? So it worked. It just. So it worked. It just. Okay, let me try it looking at this. If is recording goes true. Oh, you know what? I know what the problem is. The problem is this. Let's try that. Basically, the because it's only checking if they're being pressed, it'll constantly loop. Okay, let's try this. Okay. let's try this. Okay, I have to figure. I have to figure that out. I have to figure that out. That didn't work anywhere near expected. But look at this. That's a video recording being saved. That's my arm and my hand moving. Look at that. We did it. Now we just gotta do it with, like, you know, not garbage. So first of all, let's say key 3, not key 1. Let's just try that. What? No. No, hang on. Let's try that. Let's try that. I can't guarantee you anything's gonna happen. But, well, okay. Oh God. Oh no. Oh God. No, that didn't work at all. Because I have 1,000,000,000,000 videos. Okay, let's think about this. I'm literally saving a video every millisecond. You lol. Um, I think I'll get back to this in the morning because it is late. And I'm thinking about this, and it seems to be not difficult. Just when I'm fresh, I'll think about it. And man, I just joined back. I get my head into bed. Um, let's just try building it again, just so that we can end on a good note here with some screenshots and videos. Let's do that. So we're gonna take a screenshot, and then we're going to my God. That's okay. Okay. Let's take a look. So we're going to open the screenshots folder, and we're going to have a trillion screenshots. So we have a screenshot there. Okay, so we got screenshot. Look at that. Isn't that beautiful? And then let's open up our video. It is beautiful. The delay, I think, is just the delay I have in there. I gotta get rid of that. Or maybe not. Maybe it was just I had to download the video. So this is the clamped values. Now I just have auto gain, or auto temperature values. So I'm moving the sensor around. Now that's my arm. It's waving. Isn't that crazy? Isn't that crazy? I think that's pretty dope. So with that, I'll go to bed, and then later on I will try to work on the debouncing problem, and then it should be kind of ready to, the code should be ready to clean up. It should be ready to be put together as a portable unit, and then I can work on frame multi-sampling in AI. Right? Ain't that pretty crazy? Because, like, think about it. It's like, this here is what I'm working with. I know how to code. I know what I'm doing. Sometimes. Whew. Okay. And with that, I shall go to bed. See you later, man.